Okay, so we have let negative 3, 4 be on the terminal side. So the first thing you want to do is you want to draw the picture. You want to say, where does negative 3, 4 go? That's negative 3 on the x. That's 4 on the y. That goes to there. The triangle is formed with the origin and the x-axis, always. So then our theta would be here. So this is negative 3, this is 4, and we do the Pythagorean theorem. Well, I don't. Did you do the Pythagorean theorem? You did?
Yeah.
You can. Or you can memorize it, 3 and 4 when they're the sides. You did really nice. 3 and 4 when they're the sides, then the hypotenuse would always be 5, using that triple. But if you use the Pythagorean theorem, that's okay. It just takes you longer. Gives you more work. Okay, and then we just had to find the sine, the cosine, and tangent. So our sine, our cosine, and our tangent. Something as I walk around, I notice people not writing sine of theta equals. They're just writing sine 4/5. It should be sine of theta equals 4/5. So we can see here, what's the piece of information we don't know the value of? Theta. What's theta? What does that represent? It's an angle. You should be able to look at this and say, the sine at the angle is equal to 4/5. The angle I don't know. So cosine of theta was negative 3/5. And tangent of theta was the one I was talking about, pulling that negative sign out front because it was 4 divided by negative 3, which makes the whole fraction negative 4/5. And the next one, we had a lot of trouble because we didn't draw the XY chart. We went just straight to drawing a triangle. You got to know what quadrant it's in. So I look here and I see that tangent of theta is negative 5/4. But, okay, now we're in pre-calc. We're not really going to use SOHCAHTOA so much. We're going to use that sine is y over r. That cosine is x over r. And that tangent is 1 over what? Y over x. You got to know that now. Is there something in your hand? You're wasting my time right now. Are you playing on your phone? Okay, put it away. Okay, so we have sine is y over x. But there's a negative, and you don't know if y is negative or x is negative. Can they both be negative? No, it's going to be positive. So one of them is negative. You don't know. But then you keep reading and you see cosine is greater than 0. And which formula is cosine? What over what? I'm not using those words anymore. X over r. So when I have x over r, that tells me that x has got to be the positive. Because r is always positive. Radius is always positive. X has got to be the positive number. That makes y the negative number. So now I can draw my picture. If y is negative and x is positive, that's got to be the 4th quadrant. 4, negative 5. And then you are going to have to do your Pythagorean theorem for the radius, which ends up being square root 41. And it asks for the sine of theta and the secant of theta. Now, I know the group in the middle, you guys made this into a unit circle, which is totally fine. I don't feel like I need to do that extra step because I know that sine is y over r. I can just do y over r and rationalize it. You end up negative 5 radical 41 over 41. And then secant is r over x. So I do r, which is square root 41, over x, which is 4. Now, if you made that into a unit circle, you would still get the same answers as long as you don't make some mistakes. Okay. Questions? Draw the picture every time. So the next one, what should you do first? Draw the picture, okay. We need to know the sign at the 4 quadrant angles, and they tell you the angles. 0, pi over 2, pi, and 3 pi over 2. So there's 4 different colors, that's each of them. What do I need to find the angle when it's actually on the axis, and not the angle, the sine, cosine, tangent, if it's on the axis, what do I need? The ordered pair, I need the ordered pair. So that would be 1, 0. So I can't tell you how many papers I graded last year in both Algebra 2 and Pre-Calc where they put the X and the Y in the wrong spot. I got it wrong because you don't know how to write an ordered pair correctly. I hope we all know that when I go this way, it's 1, and then I go up nothing. We all know that, right? If you race to get through stuff, you make silly mistakes sometimes. So please take your time to think about those ordered pairs. Okay, so then sine of 0 is the what value? The y value. So 0. Sine of pi over 2. Sine of pi, 0, and sine of 3 pi over 2. Okay, now we're doing find the reference angle for each of the following. And it says right above it, the reference angle is the positive acute angle formed by the terminal side and the x-axis. So I would first draw a picture, 300 degrees. I'm going to start at my initial side, and I'm going to rotate around to what quadrant? 4th quadrant. And that's going to be my terminal side. It always goes between the terminal side, which is the radius, and the x-axis. So I'm looking at theta being here, my reference angle being there. So I'm just going to kind of use my common sense and like, well, the whole thing's 360. I went 300. If I'm going straight up, how much is left? 60 degrees. And then you ask yourself, is it positive? Is it acute between 0 and 90? Because it has to be, otherwise you are wrong. Next one, negative 135. We draw it. We start at our initial side. This says negative. What does that mean? Other way. Do I go all the way to this line? No. Because all the way to that line is how much? 180? I'm only going 135. So how do I find the theta that connects to the x-axis and the terminal side? 180, subtract 135, 35 degrees. Is it positive? Is it acute between 0 and 90? Okay. Last one. 2.3, is that degrees? No, it's radians, so we got to think in radians now. If it's in radians, I will keep it in radians, and I'll do everything in radians. What is it all the way around the circle? 2 pi. What is that as a decimal? 6.28. What is it halfway around? Pi or 3.14-ish. So this is 2.3. So if I'm starting here and to this side is pi or 3.14-ish, then I'm not going that far, am I? What about 2.3? My reference angle connects my terminal side and my x-axis. That's where the theta is going to go, the terminal side and the x-axis. So if I went all the way, it would be pi, but I'm not going all the way. I'm going 2.3. So if I take pi and I subtract 2.3, I get the answer. I guess that would probably be the only thing we needed our calculator for so far. Pi minus 2.3. You need to get it. Okay. We'll need it after lunch for sure. Like this, I guess you could do. You know what 3.14 is pi. You could do it without a calculator. Okay, this next little section is just some notes to help you if you need it. We talked about this yesterday. It tells you what's negative and positive in each quadrant. The acronym we talked about tells you what's positive. So when I write all students take calculus, all would mean all of them are positive. Students means what's positive? Sine. And then also sine's reciprocal, which is cosecant. But I'm just using sine, cosine, tangent. Take would mean tangent's positive, and calculus would mean cosine's positive. The other picture is a formula for how to find the reference angle depending which quadrant it's in. I do not use this because do you really need to memorize more when you already have to memorize the unit circle and the radians and stuff like that? I feel like you can use common sense. If it is in this quadrant, you can take 180 and subtract off this piece to get what's left. Like you can kind of use some common sense with this. But if you need it, if you lack common sense, or you haven't figured it out yet, this is available to you. All right. Next, find the solution that makes the statement true. Give answers in degrees and radians. Cosine theta equals negative radical 3 over 2. So this says find the solution that makes the statement true. That means we're solving for something. So you look at A, what's missing? Theta. So we're solving for theta, but what is theta? What is theta? Not the answer, but what is theta? It's an angle. It's an angle. And then if you read more of the directions, give answers in degrees or radians. Oh, okay, so that isn't an angle. So we need to know where cosine of theta is negative radical 3 over 2. This is how I would approach it. I would first draw a picture. I would next look at negative or positive. This is saying the cosine is negative. So where all students take calculus, where is cosine positive? First and fourth. So where's cosine negative? 2 and 3. So there's going to be two answers. One of them is going to be in quadrant 2. The other one's going to be in quadrant 3. And I drew my theta that connects my terminal side to the x-axis. There's two triangles. So we're doing quadrant 2 and quadrant 3. The next thing I'm going to think about is what reference angle is cosine theta radical 3 over 2. I'm not thinking about in the second quadrant where it is. I'm just thinking about normally, because I have it memorized already, what angle is the cosine radical 3 over 2? What angle is the sine a half? 30 degrees. So the sine at 30 is a half, then the cosine at what is radical 3 over 2? 30. Did you get me on that? Okay, well that comes from memorization, doesn't it? You need to make me some flashcards. some practice. Get a little Quizlet. Keep filling the chart out. Get some more chart. Okay. So this should be a 30 degrees reference angle. What is the radian version of 30 degrees? 5 or 6. All those things we have to start knowing. Okay, so that's a reference angle. That means this little theta right here is a 30-degree angle. That means that little theta is a 30-degree angle. Or pi over 6. Same thing. Okay? Now we actually need to know what this angle is that rotated it into the second quadrant. So that's 30 degrees. How do we find the purple angle? Subtract it from 180. So we'll have 180 minus 80. You don't necessarily need to show this. I'm showing it because it's notes. But 180 minus 30, we get what? 150 degrees? So that is one of our answers. That same location as radians. That same location as radians. I'm going to think about 180 degrees in radians is pi, which is the same thing if I give it a common denominator of 6 pi over 6. And I am up here, pi over 6, high, like above it. So this right here is 6 pi over 6. What's this one got to be? 5 pi over 6. It's like one less pi over 6. You could also take 150 degrees and multiply by pi and divide by 180 and reduce it. But if you just memorize this stuff and know how to do fractions like that, it's a lot easier. All right, so that's one of the answers. The other answer is this bottom one here. I'll change colors. So this other one, here's our terminal side. We have to start at 0, go all the way to that one. We know that one's 30 past the middle, so 180 plus 30, which is 210. And then we need to know what that is as a radian. This is 6 pi over 6. How many is this one? 7 pi over 6. A lot faster to do it that way than using that conversion thing. Excellent. Let's try another one. Cotangent of theta equals 1. What do we know about cotangent? Oh, you're ahead of me. What is cotangent? Reciprocal of tangent. Hi, I've admitted this to you already. I don't have my cotangent, my cosecant, my secant values memorized. I have my sine, cosine, tangent values memorized. If you're in the same boat as me, I don't like to think about cotangent. I like to think about tangent. How do I make cotangent theta into tangent theta? Reciprocate 1? Okay, so what's the reciprocal of 1? Oops. What, 1 over 1 and reciprocate it? Oh, okay, same thing. And you don't have to do that stuff. You can use cotangent. Tangent is y over x. So cotangent is x over y. You can use either. All you need to know from this right now is that x and y have to be the same number. That's the only way that when you put y over x, you get 1. They have to be the same number. That should get you thinking about what kind of degrees we're looking at. Now I'm going to draw my picture. And tangent or cotangent is positive. Where? 1 and 3. And then we think what reference angle gives us tangent equaling 1, or when x and y are the same number. 45 degrees. That's the reference. And 45 degrees as a radian is pi over 4. 45 is pi over 4. 45 is pi over 4. So now I need to find it for this picture. When I do my first one, it's in the first quadrant, so the reference angles are the exact same as the first answers. So 45 degrees and pi over 4 are those first two answers. The other one's not the same. We're going to find that one. So this other one down here, if I start at 0 and I go all the way past 180, what am I doing to 180 to get it here? Adding 45. We get 225. And then for my radians, I'm going to think about pi over 4s. The pi right here is 4 pi over 4. And then how many pi over 4s more do I have? So total we have 5 pi over 4. Are we following? Can we try the next one with our partners or trio? Try the next one with your partners or trio. I'll be right there if you have questions. I'm going to pause it. There you go. We were on, well, you guys were just doing this on your own, and I went around and checked stuff, but just to put it on the video, sine is positive in first and second quadrant, so those are where our thetas are. And I asked a few of you, what's the sine of 30 degrees? And you tell me 1/2. And this is the sine of something is radical 3 over 2, so I know it's not 30 degrees. What is it going to be?
60 degrees.
60 degrees. So that's our reference angle.
Yes.
And then we look here in the reference angle, and also it's pi over what? Pi over 3. And the reference angle and the first angle themselves are the same, so that is our first solution. And then our second one, we've got to go all the way over to here. And since we're doing pi over 3, it's here at pi is the same thing as 3 pi over 3. So to get to this one, that one's 1 pi over 3. That one's got to be how many pi over 3's? That's 3 pi over 3. That's 1 pi over 3. How many pi over 3 is that one going to be? 2 pi over 3. And then degrees, there are 60 degrees for the reference angle. So 60 less than 180 is 120. Okay, the last one is where we left off. Secant. You can use secant or you can use cosine, but you got to know the formula. Cosine and secant. What variable is cosine? X over R, so secant is R over X. And it doesn't matter which one you do, because when I reciprocate one, still 1. So either one is fine. But 1 is the same thing as 1 over 1, which, in order for X and R to be the same, the radius and the X value to be the same, you can't have a triangle. For two sides of the triangle to be the same and one of them is a radius, it's not going to be a triangle. So this one is on a quadrant. So we need to find where X is 1. And where the radius is also 1. That would be at what degrees? 0 degrees, or what? Would 180 work? What's wrong with 180? -1. And is this negative? No. So just 0. If you went all the way around again, it would be 360. If you went around again, it would be 720. I mean, you can go around as many times as you want. So we don't need to keep going. But 0 degrees as radians is 0. What about 360 as radian? All right, this is the calculator part. I'm gonna have my calculator in radian mode when I do this, just heads up, because I haven't changed it from the other assignment we were doing. Do you have yours in degree mode? You can keep it in degree mode too, you just might be doing stuff in a different order. Example 6, we're determining the value of theta. We're doing what we just did, except now I've given you a decimal per sign, so it's not one of those that you've memorized. It's not one of the special ones. So we need to figure out what angle theta is that the sign is 0.3892. So how do you find the angle on the calculator? Sine inverse, second sign, right? 0.3892. Now, I would like everybody to do this, even if your partner has it too, because I want you to kind of go through these keystrokes and start learning what we need to do. So I get 0.39976 something or another. Did you get that? What mode are you in? It's okay. It's okay. If you're in degree modes, we have to find both radians and degrees. So you could, unless you want to do exactly the same thing as me, then go ahead and change it. But otherwise, you just have to do the opposite of what it is. So this is radians. And I believe it says round in the nearest tenth. What would be the nearest? 0.4. But where's sine positive? First and second. So we should have two answers. Have two answers. Just heads up. Radians 0.4, and then my degrees for this one. How could I find my degrees for that 0.4? How could I find that in degree? If we want to convert it to degrees, then we want to multiply by degrees. So if I want to convert that to degrees, I'm not using 0.4 on my calculator. I'm leaving it, and I'm doing times by 180 divided by pi. Taj, put your phone away. Nobody can see this on the video.
Right.
All right. 22.9 degrees, approximately 22.9 degrees. So that would be our first quadrant answer. That one right there. And we also have to find our second quadrant answer. You would need to know the reference angle to be able to find this one. The green one, you need to know the reference angle. So reference angle is theta that connects the terminal side to the x-axis. We happen to already know that because of how it worked out for this one. What is our reference angle theta? 22.9 or 0.4, depending on which Those are our reference angles. That means this theta right here is 22.9. But that's not the answer. How do I find that answer? I would subtract pi minus, but don't do it yet, but I would subtract pi minus that 0.4. I would also take 180 degrees minus 22.9, but don't do it yet. Okay, but that's how I'm going to get those answers. And I'm saying don't do it yet because I want to just totally use my calculator to do it. Okay, so we have, the last thing I have on my calculator is 22.9. So since I need to take 180 minus that answer, I'm going to use the A and S button. I'm not going to type in 22.9. I'm going to use that whole decimal. So it's the most accurate answer possible. So we got 157 point, yeah. Well, it is, I'm sorry, second, and then the negative button at the very bottom. I use it a lot, so that's a friendly button to get to know. Okay, so I got 157.1 degrees. That would be my other angle. And does that make sense to where it's located, that it could be 157.1? Does that make sense? And it's in the second quadrant, 157-ish. Makes sense. Like, sometimes you type things in weird and they don't make sense with your picture. Okay, the other one I have to do is I have to do pi minus 0.4. But I don't want to use 0.4. So I got two different ways you could do this. Where is my 0.4? There? That 0.399? If you want, you could do pi minus, and then if you have the newer calculators where you can go up, if you highlight that last answer, that 0.39999, and you hit enter, it'll push it down to there. So then you don't have to retype anything. If you don't have it, you have it. Oh, okay. If you don't have the newer calculators, you do. If you don't have the newer calculators, what I would suggest is once you have, oh shoot, I gotta go back up and get this one. Once you have the, who else am I talking to right now? I know Taj. Oh, I don't know about you. I'm sorry, it's not you. He's talking about earlier. Actually, what I'm doing right now, you can totally do. So what I would suggest instead of doing what I did before is I would take that last answer, that 157, is that the last name on your calculator? I would just convert it to radians, so multiply by pi, divide by 180. So just multiply by pi, divide by 180. So, hey, and that should work on yours too. So did everybody get 2.7-ish somehow on their calculator? For radians, yes. 2.7, something. Okay. The next one. You just want to keep it as accurate as possible, so we're not using a rounded one. It'll matter more when we have to round to different decimal places. When we round to the 10th, it doesn't matter so much. It will matter later. So we're going to do the secant theta equals negative 2.3412. Is there like a second secant button? Okay. So we can't use secant. What do we know about secant? Secant is what? Reciprocal cosine. So cosine theta is 1 over secant theta, right? So cosine theta is 1 over negative 2.3412. So what do I type in my calculation? No. What am I trying to get? Trying to get theta. How do we get rid of cosine? So we just get theta, which is going to be an angle. Yeah, the cosine inverse, arc cosine, second cosine. 1 divided by negative 2.3412. Okay. And knowing what to do when is Something that comes from experience, like knowing what to do when. You did that on your calculator? Two, approximately 2. You got a big number that looks like that, 2.01211. Did you get it? So that would be our radian answer. And then we need our degree. How am I going to find degree? Times by 180 divided by pi. And you get what approximation for degrees? 115.30 degrees. So that's our first answer, but we should have 2 answers. So let's go to our picture. And since we're doing cosine, let me move the picture down. Since we're doing cosine, where is cosine negative? Second and third, yeah, 2 and 3. So here is one place, and that's the 115.3 degrees, or the 2.0 radians. And then we also have it in the third, and that's one we still need to find. But to find that one, I have to know the reference angle. The reference angle is acute, so it's between 0 and 90, and it's positive. Do I have the reference angle yet? I do not. I have 115 degrees. That is not acute. So up here, I need to know, I already have colors. I need to know this part. So this part right here is the 115. How do I find the other part of it? Subtract from 180. They're supplementary. They add up to be 180. So we take 180, subtract that last answer you had on your calculator. So on my calculator I'm using, and I'm doing 180 minus my last answer. So 64.7 is our reference angle. That's not our answer. 64.7 is our reference angle. That's our reference. Because if you look at that red one, actually the green arc, there's no way that's 64.7. It's just this part right here. That's 64.7. How do I find out, starting at 0, going all the way around, add 180 to it, right? Bless you. And since that last number is on your calculator, you can just leave it there and hit plus 180. So I have just that last answer, plus 180, I get 244.7. Does that make sense for my picture? 244.7? Does that make sense for the quadrant this is in? Starting here, going all the way to there. Does that make sense? 244.7? How do I find the radian version of 244.7? Multiply pi divided by 180. .3? 4.3? 4.27? 4.3? How do I know if that makes sense? How do I know if 4.3 makes sense where it's located? 180 is 3.14. Excellent. 180 is 3.14, so past that, 4.3, yeah, that kind of makes sense. I mean, it's not exact science, but at least we know we're somewhat in the correct area. All right, one more. Last one. Last example. Cotangent theta is 1.192. We don't have a cotangent button. What do I know about cotangent? Reciprocal tangent. So tangent of theta is 1 over cotangent theta. So tangent of theta is 1 over 1.192. So what do I type in my calculator? Type it in? What do I type in my calculator? Or are you on the other side?
I was just explaining something about the last one.
Okay.
I shouldn't write the things.
Sorry.
Sorry.
I thought you were helping with a new one. That's why I called it you. Drew, you know what's happened?
Second tangent 1 over 1.1.
Excellent, excellent, excellent. So second tangent, 1 divided by 1.192. And since I'm in radian mode, I'm getting my radian answer as approximately 0.7. Approximately 0.7. That's radian. I should. I found my degree. Multiply by 180 divided by pi. About 40 degrees. 39.99, about 40 degrees. I'm going to use my picture. And this is cotangent. And cotangent is positive, which is same as tangent being positive where? 1 and 3. That's where tangent is positive. So the first one is what we found. 40 degrees, 0.7 radians. That's the first one. The other one's got to be in 3. So we have to find, starting at 0, the initial side, how far it is all the way around. So to do that, you need your reference angle. Do we have our reference angle yet? Right, it's the same as the quadrant 1, the 40 degrees or the 0.7 radians. That's our reference angle. So how do I get all the way around to there? Add 180 or add what to that? Pi. So we're going to add 180, or we're going to add pi, depending on what you found first. Whatever's in your calculator, make it easy on yourself. What's on my calculator? Degrees is on my calculator. So I'm going to add 180, and I'm going to get 220 degrees. And I'm going to ask myself if that makes sense for that second angle, where it's located. Does 220 make sense? And then the other one is radian, but I already know what the degrees is, so I'm just going to convert it on my calculator. How do we convert to radian? Times by pi, so divided by 180. 3.8. Does that make sense where it's located?
Yes.
Why? Because what's this? 3.14, and this is past it, but not that far? Yeah. Excellent! So now your assignment is actually on the first 2 pages of the notes. That third page that we did with all the graphing calculator stuff is tomorrow's assignment. We've done our notes for tomorrow, or Friday. We've done our notes for Friday already. There's a worksheet on Friday. I've already posted on Canvas if you want to work ahead, but we're going to do that during class on Friday. Use the rest class to work on this assignment, which is on like the first 2 pages of that, of the notes today.
It's on all of it?
No, it's not on there. I mean, like, that assignment is on these notes. It's not. It's on these notes. Yeah. And then this assignment is for Friday. Like, these notes are for Friday.